In my last video, I showed you how to make an orbital diagram, which is showing all of the electrons in their different orbitals with their different energy levels and what shape is there. Now with these orbital diagrams showing the electron spins, these aren't always necessary because chemists, we want to write things a little bit faster. So once we understand where all the orbitals are actually spread out, what we can do is instead of actually showing the electron spinning in two different directions and spread out in our different orbitals, we can actually just go through and tell the reader that, hey, on our our S-shaped orbital, there's two electrons that can fit in that S shape. So if you have one orbital, there's two electrons in it. For your P-shaped orbital, there's three of them there total. On each of these orbitals, you can hold two electrons, so a P can actually hold 6 electrons total. The D works the same way. There's 5 orbitals. Each one holds 2 electrons, so we can hold a total of 10 electrons in any D sublevel. And for your F, there's 7 orbitals there total, so that holds 14 electrons total. So what that does for us is instead of doing our orbital diagram like this, where we're showing all of the electrons spinning, to make this a little faster, we're going to assume that we know that there's 2 electrons in that one orbital spinning in different directions. So instead of telling the reader that we have the 2 electrons with the 2 arrows, we just put the number 2 there. That number 2 just tells us how many electrons. Same thing here. If you have an S, it holds 2 electrons in that one orbital. For your P shape, there's 3 orbitals. Here we have 5 electrons in those 3 orbitals. So we could just draw or write the number 5 instead of writing it all out. So to do this, I have a couple examples, and it follows the same process that we just did. So if we have magnesium, with my magnesium, it lives right here on the periodic table. So I'm going to write out, again, my energy levels and my block and tell how many electrons are there. So if I have magnesium, I start up here at the top with 1, and this is the S block. Now the S block can hold 1, 2 electrons, so I just write the number 2 right there. After 1s2, now I'm dropping down to the next row, and I'm at 2, and this is still the S block, so 2s. There's 1, 2 electrons in that block. Now after 2s, we cruise across here and we see the number 2. And this is the P block, so I write down 2p. And there's 6 electrons that can fit in my 3 orbitals, but you can also count over 1, 2, 3, 4, 5, 6. So 2p6. After 2p6, I'm right here and I'm at 3, and I'm back in the S block. Now magnesium lives right here, and that's the element that we're writing. So we can just go over 1, 2 to get to that one. So we have 3s2 to end this one out. So magnesium, when we write it, is 1s2, 2s2, 2p6, 3s2. If we add up 2 plus 2 plus 6 plus 2, that'll give us the 12 electrons that are in magnesium. To do a little bit larger one, I have germanium. So germanium is down here at number 32 on the periodic table. I still start at the top of the periodic table and I go all the way through until I get to germanium. Every time you see an energy level, like right here I have 1, and that's in the S block. S's get 2 electrons, 1, 2. Now after 1s2, I'm right here, and I'm in the second energy level, S block, and we go 1, 2. After 2s2, I cruise over here, and I'm at 2. This is the P block, and we go across all 6 of those, so it's 2p6. After 2p6, I'm right here, and I'm at 3s, 1, 2. After 3s2, I go over here, and I'm at the third energy level again. I'm in the P block, and we go across all 6 of those. After 3p6, now I'm here, and I'm at 4, and I'm in the S block again, so 4s. With 4s, we go across 1, 2 elements. Now I hit a new number. That new number is 3. I'm in the D block. your D has 5 orbitals. Each one holds 2 electrons, so there's actually 10 elements across here. So 3D10. Now after 3D10, I'm right here and I see a new number for my energy level, and that's 4. So I write the number 4. I'm back in the P block. And I count over till I get to germanium. So I count gallium, germanium, 1, 2. So we have 4p2. So your full electron configuration for germanium looks like this.